Good wishes, dear students. We are beginning with the first lesson in your physical chemistry part, that is gaseous state. As you know, matter is found in the form of a solid, liquid and gas. Solid form of matter you will learn in your standard 12 syllabus. Right now let's concentrate on gaseous form of matter. To understand further the physical and chemical properties of matter and its constituents, we need the help of certain parameters. They are pressure, volume and temperature. As you know, the formula for a pressure is force by area. The unit of force is Newton or kilogram meter per second square, and the unit of area is meter square. Apart from it, there are plenty of other units for pressure is given to you in your volume 1 textbook on page number 159. You can refer to that page. Directly moving on to few laws which talks about the characteristics of a gaseous matter. The very first law was given by Boyle, so it's known as a Boyle's law. Here I am not going into a very detailed explanation. The precise explanation that is required along with the key answers I have given it to you. You can make use of it. What does Boyle's law talk about? It's based on a pressure and volume relationship. As you know that there are three parameters based on which gaseous state could be understood better. So in terms of Boyle's law, pressure and volume are considered where temperature is kept constant. Now that is what is written. Boyle's law is based on pressure-volume relationship. So when these two are considered, what is kept constant? Temperature is kept constant. So at constant temperature, pressure and volume are inversely proportional to one another. What's the meaning of inversely proportional to? When a pressure increases, volume decreases, and vice versa, meaning if the pressure is decreasing, volume will increase. You will understand better if you look at these two diagrams. Both the green color dot stands for a number of mole. What I have written here, N is same, that is number of mole is same in both the container. But here the piston is somewhat above or on the upper part of the container, and here the piston is lower part of the container. So what could we say? Here the pressure is low. When the pressure is low, volume is high. The space occupied is more. On the other hand, when the pressure is high, the volume occupied gets reduces. So the same thing in terms of law, how can we write it? Pressure is proportional to 1 by V, because we are saying pressure and volume are inversely proportional to one another. As you know, the proportionality sign can be replaced with a proportionality constant. So we can write it pressure is equals to K into 1 by V, where if we multiply K into 1 becomes K, pressure is equals to K by V. If we can multiply these two, that is PV is equals to K. This is in terms of pressure if you are considering. On the other hand, if you are considering volume, volume is inversely proportional to pressure. Now, proportionality sign can be replaced with a constant. So, V is equals to K into 1 by P, which can be written it as V is equals to K by P. If we cross multiply, PV is equals to K. So, whether you consider in terms of pressure or you consider in terms of volume, both gives us the same formula, PV is equals to K. So this is Boyle's law. Now the same thing can be represented little differently, that is P1 V1 is equals to K and also P2 V2 is equals to K. Both the places K value happens to be same, so we can get cancelled. Finally you can write it, therefore P1 V1 is equals to P2 V2. Now what is this P1 V1 and P2 V2? You know that reaction also can take place in the form of a gaseous matter. The molecules, if they are in the gaseous form. So the pressure and volume before the reaction could begin and the pressure and volume after the reaction. So this is P1 V1 talks about before the changes, a volume and the pressure of a molecule before the changes, and this one will be after the changes. So how can we write it? P1 V1 is equals to P2 V2 is equals to K here. Now this is in terms of loss explanation. Now in terms of graph, if we represent, this is in simple. I have given to you what is required for you to understand graphical representation of Boyle's law. That is P is equals to K into 1 by V as one type of graph, and PV is equals to K as another type of. That is, if we multiply P into V will become PV is equals to K. You have seen it in the previous page. So when a pressure, on the y-axis you plot pressure 1 by V, that's a proportional of volume in terms of x-axis. So if we plot the diagram, we get a straight line here. On the other hand, pressure and volume directly, if we plot on y-axis and the x-axis, we get the curved line. So what's the conclusion? When pressure decreases, volume increases, based on which Boyle's law is written or given. Moving on to consequences of Boyle's law, that is pressure density relationship. Now Boyle, and first we are talking about a pressure and volume relationship. Now in terms of volume, we are talking about a density. As you know, volume is equals to mass by density. So substituting this value into the formula which we have arrived here, P1 V1 is equals to P2 V2. I have written the formula. In terms of V1, you write it M1 and D1. I'm sorry, mass remains. I told you, number of moles remains same in both the cases. So mass will remain as it is, density alone, because they are getting reduced here. So P1 into B1 M by D1 is equals to P2 into V2. We write it as a M by D2. Both the places M value is same, they get cancelled. So we can write it. Now when the P1 comes to the numerator, P1 D1 is equals to P2 D2. So what is the final conclusion in terms of density when we consider? When the pressure increases, density also increases. Or when the pressure decreases, density also decreases. Now in this short derivation, M is equals to mass, D1 and D2 are density of the gas, and P1 and P2 are pressures. So the final conclusion is density of the gas is directly proportional to the pressure. So in terms of volume, it is inversely proportional. In terms of density, it is directly proportional to the pressure. Hence we say if pressure is increasing, density also will increase. If the pressure is decreasing, density also will decrease. So moving on to the next law, that is Charles' law. In terms of Boyle's law, we considered pressure and volume. Temperature was considered to be constant. Now here volume and temperature we will consider. So the third parameter, pressure, is kept constant. So what does this law talks about? At constant pressure, the volume of the gas is directly proportional to the temperature. You understand the meaning of directly? If one is decreasing, the other one also will decrease. If one is increasing, the other one also will increase. So here again you can look at this two container. Here hot water is kept, a balloon is kept on it, and here cold water, and again a balloon is floating on it. So when the temperature, hot water, temperature will be more. When the temperature is high, volume of the balloon also will be high. Ice water, temperature is low, hence the volume of the balloon also will be low. If you understand so much, you can go in for the law, that is volume is directly proportional to the temperature. Proportionality sign, replace it with a constant. V is equals to K into T. To calculate the value of the proportionality constant, T can be brought to the denominator. So we can write it V by T is equals to K. So here again, before the reaction and after the reaction, you remember P1, law is PV is equals to K. So if you are talking about pressure and volume before the reaction and pressure and volume at the end of the reaction, we can write it V1 by T1 is equals to V2 by T2 is equals to K at different conditions. Moving on to the third type of law, that is Gay-Lussac's law. So here pressure and temperature are considered. In a Boyle's law, pressure and volume is considered, temperature is constant. In Charles' law, volume and temperature are considered, pressure it at constant. But in terms of Gay-Lussac's law, pressure and temperature, volume is a constant. Easy way of understanding. At constant volume, Pressure and temperature are proportional to one another. So how do we represent it? That is when P is proportional to temperature. That is P is equals to, proportionality sign can be replaced with a K. P is equals to KT. Here again, to calculate the value of the proportionality constant, P by T is equals to K. So at different conditions, P1 by T1 is equals to P2 by T2 is equals to K here. Moving on to the last one, that is Avogadro's law or Avogadro's hypothesis. As I told you, there are different parameters based on which we understand the gaseous form of matter better. In terms of pressure we have seen, in terms of volume we have seen, in terms of temperature we have seen. Now we are going to see in terms of number of moles. So that is under Avogadro's concept. So at constant pressure and temperature, the volume of the gas is directly proportional to the number of moles of the gas, which is represented as a N. So volume is directly proportional to number of moles, that is N. Proportionality sign is replaced with a K. So, V is equals to Kn. So, to calculate the value of proportionality constant, V by N is equals to K. So, at different conditions, when I say different conditions, before the reaction and after the reaction, V1 or at a certain point of the reaction, V1 by N1 is equals to K and V2 by N2 is equals to K, which can be put together like the other cases. V1 by N1 is equals to V2 by N2 is equals to K. Moving on to the very last concept in today's class, something called ideal gas equation. Now what's the meaning of ideal gas? The gas that behaves perfectly, 100% perfect in its behavior. No gas behaves like that. Every molecule or every constituent will have certain flaws there. But if we imagine a gas to be perfectly fit, now that relationship is given here based on all four parameters, that is in terms of volume, in terms of pressure, in terms of temperature, and in terms of number of moles here. So we call it an ideal gas, the gas that obeys Boyle's law, Charles' law and Avogadro's law. There are little more concepts to it. I will explain to you in the next class. Right now you remember, ideal gas is called the gas, those gas which obey all the three laws here. Boyle's law, volume is proportional to 1 by pressure. Charles' law, volume is proportional to temperature. Avogadro's law, volume is proportional to number of molecules. Putting it together, because everywhere volume is proportional to inversely proportional to pressure, temperature, number of molecules. If you write it together, volume is proportional to number of molecules and temperature and inversely proportional to the pressure. Now, N into T, if you multiply it together, we can also write it V is proportional to NT by V. As usual, the previous four laws, we replaced the proportionality sign with the letter K. But here we are replacing it with a capital R, that is a gas constant. V is equals to, instead of this proportionality sign, we are replacing it with the R. So V is equals to RNT by V. For the sake of rhyming, you can also write it as V is equals to NRT by V. By P. If we cross multiply, PV is equals to nRT. It's known as an ideal gas equation. So here again, R is called as a proportionality constant or called as a universal gas constant. One and the same they are. Moving back to understand what's the meaning of universal gas constant. The value of gas constant R can be derived from PV is equals to nRT ideal gas equation. That is, R is equals to PV by NT. Rearranging the formula, I have got it here. Now there are two conditions. Under normal conditions, what will be the value of R? And under standard temperature and pressure, what will be the value of R? So pressure value, volume value, and a number of molecules and a temperature. Under normal conditions, you get the value to be, if you work out the numericals, 0.0821 decimeter cube atmosphere per mole and per Kelvin you will get. But in terms of standard temperature and pressure, if you substitute the values, you get the gas constant R value is equals to 8.314 joules per Kelvin per mole. Now when we work out the numericals, I will tell you when to substitute the value, a value of R to be 0.0821 and when to substitute 8.314. It's easy. Under normal conditions, the value of gas constant R is this one. Under standard temperature and pressure, the value of gas constant is 8.314. Thank you.